Thank you everybody for joining the webinar today. My topic today is about big data and AI in fighting against COVID-19. And a bit of disclaimer. I'll share some technologies and I have some opinions and thoughts. These are all myself and not anything to do with my company. Since I also talk about some of Amazon competitors and their product. Okay. So we have about 40 minutes. I will give a quick introduction and tell you everybody how I get started on looking into COVID-19 with big data and AI. And then I will share some supercomputer and HPC initiative from US government called Consortium for fight for COVID-19. Then I will talk about some of the open data lake. I mean, open data set, but the data lake is a set of technologies run on top of data lake or on top of the data. I'll talk about some of the initiative from Databricks and Google and Amazon. Finally, I will talk about a particular AI use case using BERT to answer scientific questions. Yeah, I won't repeat what Bill's introduction, but my focus is to help enterprise to solve their data issue. So first is about the motivation, right? We know that the COVID-19 in 2020 started, and around the March timeframe, I know that we suddenly realized that in the US, people are scrambling to, school is shutting down, people are sent back from the company, employees sending companies sending employees back home, and city are locking down. So at that time, everybody scrambled, try to figure out what to do. At that time, there's this initiative that I personally get involved when I was working with some researchers in MIT. At the time, I was trying to help them to do some deep learning and researchers, not directly related with COVID-19, but because of COVID-19, everybody's switching back to focusing on how to provide support for that. And then I get introduced to this particular White House initiative, where a number of organizations have been called up to work together to open the computing resources to the researchers all over the world. So that is one of the starting point of my motivation looking into this. The second one is while I was looking on this, everybody talking about how to help, but at the same time, also government had a call to action to ask all the tech community to start the initiative to share the COVID-19 data set. And we're looking on the reported confirmed cases of deaths across the world, and the remote need to be understood, and that is how I start finding out many tech companies are building the data lakes. So this is actually the starting point. I didn't know I get this far by looking into this. This is my second time I give this talk, and Bill actually probably heard my other talk, and then he found me, and I have opportunity to just collaborate and learn from everybody together on this. I think we are still in the very beginning of this from research and science perspective, but more to come. First topic, when we say big data AI, we know a bigger part of it is computing resource, and computing resource means that GPUs or large machines, supercomputers, or maybe some computer engine or EC2 on cloud. So that is for small research. That's probably not a big problem. But when I was working with the researchers in MIT, I understand the bigger part of their budget or effort is getting this environment up and running to help them to support their research and collaboration. So this COVID-19 high performance computing consortium is, response of the government call to action. A large number of organizations, starting from IBM, in fact, and also DOE, but then quickly I get to most of the major HPC vendors in industry, or universities, and particularly also government, the federal government, DOE agencies, research labs, and such, and actually they open this consortium to all researchers, so that if you want to do research, you can submit the application and get free assigned, large supercomputer for you. A little bit about supercomputer consortium. On the left side, I talk about one of the environment is called the Summit. It's the largest supercomputer in the world, and it's IBM with Oak Ridge National Laboratory in Tennessee. This one comes with 200 petaflops, which pretty large environment, and take years to build. Probably hundreds or thousands of researchers are already using this for their research, and nowadays they are open for COVID-19 with a fast track. In the middle, I lay out some of the Amazon Web Services high performance computing stack. So you know that if you come into the computer hardware and the high performance computing, you know that the many companies now, particularly big tech companies, are now developing their own hardware, both for compute and storage and networks. So you see Amazon had a very new type of C-types, M-types instances with very large number of processor, and for both traditional data intensive or memory intensive or IO intensive workload. Still with EC2, a special FX for raster file system, which is high performance for like a medical research like genomics. And then we also have our workflow. I mean, basically, it's not a single job. It's a chain of different processes, large and small, with different type of compute patterns. So Amazon provide a list of tools and the process to build that workflow and publicize it and to make it happen easily for researchers. And at the bottom, you see that one of the benefits use cloud or supercomputer in today's world is how quickly you auto scale a large environment. So if you see in this diagram, it's pretty classic, but it's HPC ready. Means you have some of the tools which called template called CloudFormation. You build a large environment in a configuration template, and deploy it with all the resources like storage, network, compute, even the backup and anything or different code. You also have the auto scaling capabilities so that you can make, you know, two node or 200 nodes quickly. This is particularly important when, you know, in COVID-19 days, that people don't expect what to, you know, the next day or next week, you need to do something, you know, so much different than, you know, last month or yesterday. So the highly elastic and scalable architecture in cloud give people a lot of flexibility to do so. And I think people really appreciate that. On the right side is a small cluster, small in the sense is compared to that, you know, the largest one, but it's still very powerful. It's 64 nodes cluster, and you know, come with IBM Power 9 systems and GPU and the special, you know, NVLinks. So they have also, I mean, even in MIT, we have this cluster. We also share with many other researchers in, you know, Harvard, Yale University, and Duke. So NIH. So what I mean is it opens a lot of collaboration opportunities, which wasn't there before until COVID-19. Then, well, as I mentioned, that the process you submit the project, and then oh, I want to just mention one thing. This here, the petaflops is the number. How do you calculate the you know, scientific computing operations? But this whole consortium account with like 5 million of CPUs. 50,000 of GPUs as such, so it's a lot of computing resource, computer power there, probably bigger than any large, you know, big data center or large companies' data center operations. And yeah, so these are all the researchers. I mean, if you deep into the medical research, you probably know more than I do, but there are 3 categories of proposals they accept. Basically, basic research, how, you know, understand the virus, and also therapeutic. It's kind of try to find how to cure or find a drug or compound to discover drugs and the medicine. And also there's category of patient. So how to do the treatment from clinical perspective, how to understand the epidemiology aspect of, you know, how virus are passing around all over the world, and also supply chain and like hospital resources for equipment and such. So yeah, so I think right now they are adding a lot of proposals there. So pretty successful initiative. So this is my first topic. The second topic I want to open up is about data lake. And probably if you in big data, you probably know big data lake is something between the database or data warehouse, getting data like prepared for feeding into your data warehouse, but it usually comes with the streaming data or like a batch files, a large number of unstructured data in different formats. It's hard to, you know, govern and indexing, catalog. It's difficult to build, but I was surprised to find out in COVID-19, many companies are suddenly seeing opportunity to make some new strength in this area, and they have been showcased a pretty successful few use cases. The first one I would say it's something I found out from Databricks. I just watched the the Spark Summit, the AI Summit conference video this morning, and they released the Spark 3.0. So they have a bunch of other, new machine learning and data, big data products. But this data lake actually gave me an opportunity. Basically, this link, I have a blog, and it gave me a good overview of many of the common use cases people are doing and dealing with COVID-19 tracking and prediction. So on the very left, you see this is like a map, but basically they take the data using a notebook, taking the data from Johns Hopkins University. And because of the data lake, you can actually somehow, because the Johns Hopkins data is also open, so Databricks had a way to just build a data interface to pull the data to ETL and get data ready for people writing a notebook like that. The middle one is genomics epidemiology map. This company called, I think called NextChain or something, NextChain. You can just go to their website and see the real-time, passing about the genomics epidemiology. Basically, particularly in early days, when you have first few hundred, few thousand cases, researchers are getting this data tested to see their virus and understand the relationship between them and try to create a map to understand, where this different virus and coming from where, when, and how. So this is not something called Databricks produced, but by a company. But the Databricks had a way to, source that data into their data lake and to showcase a potential opportunity for anyone who can, combine this data to advance the, tracking and prediction. Then on the very far right is University of Washington. They actually taking that data and build some predictive model to understand the hospital resources utilization. And you know that particularly in March and early April, everybody is so much concerned about the hospital's capacity in facing the first wave of COVID-19. So this gave a lot of people a good way to understand how, one particular organization doing it, you can learn from that, you can do something on top of it, you can do something different. The data somehow is there and also for you to explore, right? So while I was looking on Databricks, Data Lake, I saw some of the cases, some of the data not only just published on Databricks, but also somewhere else, particularly on Kaggle. So this answer key questions from scientific literature is actually my, at the end of my presentation is my NLP use case. But initially I actually found out from Databricks Data Lake. And then I found out more sources. They gave a link. I found this in Kaggle. And later on I found out more stuff from Google and Amazon. So it's a good kind of like passing things around and see how people doing the same thing differently. And yeah, of course, there's also medical imaging use cases. My team in Europe, they were using some, non-COVID-19 data, on top of the tree model with COVID-19 data, build a classifier for imaging. And that's good to source that data, because getting that type of imaging data is not always easy. This is a little bit a busy slide, but I think the takeaway I want you to have is this is basically the same thing Databricks did, but Amazon can do very similarly. I mean, if you look at Google's data lake from data perspective, they're pretty much the same, but also different. The same is they have some data set are pretty much common, like global coronavirus data, see how many cases where, right? And then, I mean, this is probably the first time you will get the data like globally and in a real-time basis being watched and tracked by people. And while I was playing with that John Hopkins data, one thing I found out with the notebook from Databricks is you find out their data model keep changing. It means that, you know, when you add a new country and a new field, or, you know, you want to merge some data, then their side of schema are changing. And my code being working today may not be working tomorrow morning. It's been changing several times. So it still needs some effort for people to maintain that type of transparency. Because not necessarily, you know, John Hopkins will notify you or send you an email about exactly what they did. But for that, you appreciate the people building the data lake and prepare that data for you and show an example how they did it. And if something happened, you can trace back and see where it's broken or such. I'll leave some time at the end, but I don't think I can. I have this. If I click this link, it'll bring up this page. And I think if I bring up now, do you see my screen or no? Yes or no? Nobody see it, right? Do you see? Can somebody?
Yes, we can see the screen.
Oh, you can see. Good. Okay, that's really good, because I was worried about that if I can demo this using this slideshow thing. Yeah, so again, this is something from technology perspective. It's also something called you know, Amazon tools. So they have different tools. So for one thing, I will say, you know, to build a data lake, the foundation part is you need a very robust browser, like a data browser or Explorer, and not all the company building that intuitively. So Amazon using S3 Explorer, although it's not a very fancy tool, but I gave you an opportunity to quickly access that data. And also they have a Glue, which is a ETL engine, and also a SQL query engine. And I think these are the core components for you to build a data lake, although they are very, very, very easy to use, I would say, because they just focus on one task and they try to do the best. And so when they deploy this using the CloudFormation, basically you can build a data lake on Amazon in your account using the template. Of course, on top of that, you could customize it, but at least you will see from the beginning how it will look like, and you can source that data back to the data lake and data point. So they have many kind of this type of dashboard from different country, and hospital in the sense, you know how many ICU beds and stuff bed. I mean, if you're really into the research in this domain, you can just look at one or two data lakes, and they usually come with a dashboard. Or one thing I would say is this, because I just looked at it today and I found out preparing this slide, I realized this. One second, where's my mouse? Okay, here. Okay, so if I go for the Explorer, then you see basically like a tree structure. You can see even you can get a tabular or something else open here. They're usually JSON and CSV file, but they also build like a HTML page and get all the dashboard. But this one actually from Tabular. So I guess is, you know, Tabular is not a cloud company. They're a software company, although they build their own private cloud or public cloud, but they also use Amazon as a platform to make their product available, marketable for their customer. So they probably use this data lake to showcase their, you know, example of their visualization and dashboard capability. That's something I think worth to point out. So this is a Google's data lake. I won't go for too far into this. It's pretty much the same. Again, for the convention data source, people are talking about, probably there are many. There's the John Hopkins, New York Times. If you go to New York Times website, COVID-19, they also have a beautiful dashboard. And there's also, you know, US Fact website, and also the European different country, they all build their own, because they get their own data updated and then also populated across the world to different countries. But I think the Google also have their own tools for data lake. I just want to show one example here for their BigQuery. So if you know that BigQuery can do federated query, means that you can take multiple data source and do you know, aggregation and summary. So you could use their example, because the data lake, when they build a data lake, they create document, they create a use case, they use the data and say, if I want to query, this is February's data, and so I say if I take June. So you can run the data using SQL, right? So I didn't show you how I use Databricks. It's the same type of notebook. You can take the data using Spark or PySpark or Python data frame. But you know, it's also very common. You can use SQL, but high performance SQL per se. I mean, for this type of workload, probably it's not a big deal. But you get to learn something new, right? I would believe that these companies are trying to present the best of what they have to give their customers and showcase their capability, right? It's an opportunity for them to do so. So you got to trust what they do is what they try to promote over here. Let me check my time. Okay, yeah. The last one, I will talk about a little bit about the NLP and BERT. I'm not so much too expert, because I actually use this opportunity to learn BERT. I heard about it a lot, and every time I talk to people about this, people get excited. But until today, I was able to just do it. Okay, so what is NLP and BERT? There's like a media article or something, which I think I take the picture here, which I think illustrates very high level how you can use this BERT to create a better AI application. But in short, what is BERT? BERT is a context model, capture the relationship in bidirectional way. So if you have a statement that say, I made a bank deposit, the non-bidirectional way is understanding from language perspective is I made a, and then try to predict bank at either the label or masked prediction of what the word could be. But only now using BERT, you can use deposit. So you use the context of bidirectional left and right, right, left, so that you can make the most of the data for the context. So that is a very briefly, 30 seconds of what BERT can do for you better today. So if you see this, the core here is this pre-trained model. Pre-trained model is kind of, sometimes people say, okay, it's a transfer learning or something, but it's really some company who had a lot of data, build a largest use the best researchers or data scientists or a machine learning engineer working together for millions of dollars. Finally, they train this cutting edge model, and they can do very best in a particular data set, like a Wikipedia or something. And then they publicize it and say, okay, other people can use it. So people will be able to use it for training the same data set. A lot of people use the same data set to mimic what the researcher did following their paper, and see the result, although they use the different hardware, maybe use a small set of data, and then use different architecture, neural network, and then and maybe build a additional fine-tuning layer somehow for that model. But basically, they try to do something from that perspective. But my point over here for COVID-19 is you can quickly apply this model for a variety of use cases if you know how to scale this up, right? Scale this up means that you will take a different pre-trained model from BERT. Because if you know into BERT, you will know a little more. There are many different BERT models, and then you can apply the data and tune your model and see different application. And in fact, the other day I was talking to people, and people asked, "Do you have a financial BERT?" I said, "I don't know." I Google it. Yes, there's one, or maybe two, maybe a few. So maybe tomorrow will be 3. So what I mean is this is a fast growing area. People are anxious try to see and test this to make their own use case and application. Right. So this is the particular use case or data set I was looking into, again, beginning with the Databricks use case. And then at that time, you look at it in April or May, they probably only had like a 30 or 40,000 articles. But today, or maybe last time I looked at it, it's about 150,000 articles. So there's a lot of research going into this space every day. So the challenge in Kaggle is try to answer these 8 questions at the far right bottom part of it, the 8 questions. What is known about transmission, incubation, and the environment stability? What do you know about COVID-19 risk factors? What do we know about the vaccine and the therapeutics? What do we know about the virus, genetics, origin, and the evolutions, and so and so. So, but it's only 8 questions, and see who can train a good machine learning model to fetch the best answer from that 158,000 articles. Use machine, not manually, right? So that's competition. So Databricks showed some example, but if you go to Kaggle, there are more. But to start off, just basic NLP. So my topic here is the first solution called Explore COVID-19 scientific literature. So you can use word cloud, have this, things in notebook, pretty simple to take the title and then and draw the word cloud. So on the right is actually BERT. BERT had a summary model. So you basically take a BERT extractive summarizer, and you can find it into PyPy. So if you search it there, it'll be probably like a 30, 40, or maybe more for BERT. But this will be there, and then you can do pip install, and then you can use it with very straightforward syntax in this particular notebook. So what it does is take the very first record of the abstracts and then make a summary here. So this is the first example. The second example also using BERT, but this is something I found in Kaggle. If you're into this, you can just go to Kaggle. There's other few I don't have time to go over, but I think this one had a good, animation to tell you what exactly it work, how exactly it works. So on a very high level, it's not just using BERT summary model, but also use something on top of it. The previous example is trying to get a summary only, but here you come with a question answer. So people enter there's 8 questions, right? So I enter that question and then I see if I can get an answer. So there's this part of it, they done with a QA model. And then there's also part of translation. So once you get somehow the result, you can also translate it into Japanese, Korean, or Chinese. Because the research, right? I mean, people are used to their native language or something. So this is second example using BERT. So this is third one. Third one is from Google. They're actually also using BERT to create a web application to research. It's called Explorer. But you can ask follow-up questions. You can highlight certain text that build your query, and then build a follow-up query and prediction. You got to understand the highlights of the snippet, right? So I think that is pretty cool, I think, yeah. So if you're interested, there's a paper tell you what they did, although I don't know they open that code or not, or GitHub or something. I haven't got time to look at it. This is probably my last slide, because yeah. So this is the one from Amazon, because when I was looking on this in April, March, I didn't know there's such a Explorer also from Google, from Amazon. So later on I found out, oh yeah, Amazon also had the same thing, although they can be more generalized to answer different questions. Different question like a QA, right? So the example question here are somewhat different than those Kaggle Databricks question, right? 8 questions can be different. So that's because the more question you run against this data set, you see different result. You can judge or evaluate how good this AI is. But I think the Amazon one, I didn't find the research paper. I think there's a blog, but the blog is really talking about how you deploy this application on your own. They use the same data set, but use different tools to build it. I believe this can easily to duplicate it if you want to. So in fact, when I get time, I probably want to do that also myself, because there's some new graph, knowledge graph product which I like to understand and see how they use it in conjunction with the traditional machine learning and deep learning stuff. Yeah, that's I think it's 11:49. I mean 1:49 at my time. So I think.
Yes, I think since you're going to have to go for your next meetings, maybe we can go into Q&A, so we can have some question and answer discussions.
Yeah, I have. Yes.
Okay. Can you go to the Q&A? I think we have some questions in the Q&A.
If anybody, I don't see the chat.
You can just click the Q&A.
Yeah, let me see.
In the room.
Yeah, 1 second. Let me. Oh, okay. 1 second. Yeah, I see it.
By the way, for the attendees, if you have questions, you can either type in the Q&A, or if you want to prefer to speak, you can raise your hand. I can unmute you, so you can talk too.
Yeah, I answered the bottom one. Yeah, I made some update this morning, so I need to clean it up a little bit, and then I'll talk to Bill how to share with you. But you could also contact.
Yeah, you can send me the link, and I will share to the attendees or attendees.
Right. So if you find me LinkedIn or something, Twitter or something, yeah, or you can talk to Bill. I'm new to this platform, but yeah. Okay. I'm going from the bottom to the top. Professor Gary claimed that a new type of hybrid AI is needed. Do you agree? Yes. I guess your question here is about like the debate between deep learning, how successful they are, what's the limit. I kind of agree a hybrid AI is needed, particularly when you see this particular case, people using knowledge and the graphs. I think, data can only tell you that much. You don't know the context, and however, whatever you can do to make a better product, then you should try it, right? And still, right now, people are debating, well, which is better. I think only time will tell. But direction-wise, there's a lot of graph, knowledge-based research on that. And the question is how efficiently you can be able to scale this into different application. Because you've been very successful something, very narrow area, and then claim to be very successful, then you create a bubble. People don't really understand how scalable this is. But I agree with you, it should be a hybrid AI. CYC AI product claim to be able to ingest query text document. How does CYC compare? What is the CYC? Actually, I don't know this one. CYC. Well, I guess maybe I'll just assuming that an XYZ project claimed to be ingest and query text document. Ingest and query text document is nothing new. It's been there like for maybe 50 years. Since I was in college, we've been talking about doing this. Again, compare A to B is about the use A and B as a tool to solve 1, 2, 3, 4, 5 until 1,000 different problems, and then you want to see, on average, which one does better, right? So you can easily say one is better than the other one if you put more, time, make it best. But the other people just take 5 minutes, get it done. So which one is better? I don't know, right? So it's kind of each you do the benchmark this in different way, and maybe 5 minutes is good for some people, but 5 years is good for some people. That it come with both come with value. Okay, I'm going back to the bottom again. How can I implement a clinical BERT? Can you give resource? I would say, you can just go to Google to just try to see clinical BERT. I think I saw it somewhere, maybe this one. Because you could possibly just go there and particularly looking on the GitHubs. and then and see where and understand how they implement this, what data they use, and what application they have created. Read some paper, some GitHub, and try your own data. But clinical data is actually a very broad term, right? BERT is only done with like Wikipedia and book corpus. But people are saying it's quite promising. So to give you some time, right? I mean, Google just deployed the BERT last quarter, 2019, not last quarter, end of last year, into their, into our homepage, the query engine now using BERT. So it's pretty, research has been there for 2018, but for them to implement a good solution in production still takes some time, right? So even when you try it, may not be so much successful. It doesn't mean it's not. It's because you don't have all the resources to do it right, maybe.
Okay, Andrew, we have a person want to speak, to ask questions. Hey, James, I unmuted you. You can talk if you prefer to ask questions. Please go ahead. Hi, James. I think you need to unmute to speak. Okay, we probably need to come back to him later. Do you have other times? Do you have more times too? I see you have quite a lot of questions here.
I have maybe 1 to 2 minutes.
Okay, maybe
I'll answer them.
Maybe take a couple more questions.
Yeah, I think I'll probably answer this in a generic way.
Sure.
Because not knowing, I mean, I'm not the expert on everything. I don't know everything, but I could have an opinion, but I can be biased also, right? What I think is these type of research are still very active and dynamic. So what you